Hello. Whoa. 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 Oh, well, that's new. Anyway, so, you want to be Sebastian Lague, but in Godot. Or maybe you just want to mess around with physics, own your own solar system or something along those lines. Or maybe you're just messing about in general with no care to actually do this, but just liked the thumbnail. Either way, you're here, and if you did want to learn about that, the good news is you're in the right place. The bad news is the current state of the world, but let's just ignore that for a few hours and learn about implementing gravity in Godot. So, what's the formula? What is the equation to simulating an entire solar system? The gravity equation, of course. The equation states that the force we are applying to each object is equal to the gravity constant multiplied by the mass of the first object by the mass of the second object divided by the distance between the two objects squared. Okay, so let's get to implementing this in Godot. To start off, let's make a planet. I'm going to create a rigid body so we can use Godot's physics and add a sphere mesh and collision shape. But you can replace that with your own planet's meshes and collision shapes later if you want. I'll also create a sun, which will be just like our planet but with a glowy material and a light. Quick side note, I did experiment with using point lights as the sunlight for a while, but the point light shadows were rather unpredictable and glitchy over large distances, so I find it was better to have a directional light that would just look in the direction of the player constantly. This will make objects near the player have much better lighting at the expense of distant objects and planets having incorrect shadows. As well as this, I have set up a very useful global script to hold variables which are useful to access anywhere in the project. This is done by going into the project settings and adding your script to the autoload list. Once this is done, we can access any variables or functions, such as our player node, or an array of celestial bodies in any script. Anyway, back to our planet and sun. Let's add a script to the rigid body nodes called celestial body. In this script, we will add the variables for our gravitational constant, initial velocity, and a bool called isSun, since we may not want our sun node to move. The mass variable is already built into the rigid body node, so we can just use that. And we will calculate the distances between objects later. In the ready function, we will set the linear velocity of the rigid body to equal our initial velocity. We will also add the rigid body to an array of celestial bodies which is stored in the global script, which will be useful later. Next up for the physics process. We will check if the body is the sun, and if it is, then we will make sure that it stays still by setting the velocity to 0. But if it isn't, we will calculate the gravity in the function, which I've creatively named gravity. In the gravity function, we need to loop over all of our celestial bodies in the scene. Luckily, just 2 minutes ago, we added them all to a globally accessible array in the global script. So we can just say for all of the bodies in globals.celestialBodies that are not our own body, we will calculate gravity. First, we will retrieve the other body's mass and store it in a variable. We can then calculate the direction towards the other body by subtracting each body's translation and then finding the distance by using the dot length function on the value. Finally, we can use the gravity equation to find the force that we want to apply by multiplying g by the current body's mass by the other body's mass, and then getting the force by multiplying the force magnitude by the direction dot normalized. Last but not least, we can apply force to the rigid body. Whew. This script should be added to all of our rigid bodies which you want to be affected by gravity in the game. Remember, the mass of each body is what determines its gravitational pull, so make sure to set the sun as something high and the other planets to something else accordingly. We'll also need to add some initial velocity to the planets to make sure that they orbit the sun. Finally, before we test it out, we're just going to need to make sure there's no damping applied to the rigid bodies in the project's physics settings. When we run the project, we can see the planets orbiting the Sun. We can duplicate the planets and change the mass, scale, and initial velocity to see all the different results. Here's a solar system I made earlier using Ombaro's planet generation technique and Xyland's atmosphere plugin. Honestly, watching them dance around is pretty mesmerizing, but what if you wanted something less mesmerizing and more reliable? This is a physically realistic solution, similar to those in games like the Outer Wilds or Sebastian lagues solar system videos. However, it can be very unpredictable and is not always very performant, especially with a large number of bodies or complex collision shapes. There is another, more controllable and better performing solution if you want to have an easier to manage game set in a solar system. And that solution would be faking it, by just rotating each planet around a point. Yeah, honestly, in any actual game where you want a performance solution, this is probably the best. To do this, we will change our planet to a static body instead of a rigid body, since we don't need the physics anymore. And then we'll add the whole planet as a child to a spatial. The spatial will be the center of the orbit, so move the planet's static body away from the spatial, since that will be your radius. Finally, we'll add this script to the spatial, which will just rotate it at the assigned degrees per second. It's super easy to add moons for this as well by just adding our orbiting spatial as a child of the planet you want to orbit around. This gives us much better performance in larger solar systems, as well as just generally being much easier to create large systems that don't slowly fall into chaos within 10 orbits. Anyway, there you have it guys, 2 solutions for solar systems in Godot, one being a realistic gravity simulation and the other being a more practical solution to fake the orbits. All of the project files are linked in the description, and of course, if you enjoyed the video, please subscribe now. Thanks, I'm glad that didn't need to get messy. Anyway, have a nice day.